So welcome everybody to the second webinar in the fall speaker series of the local Philadelphia Informs chapter. This evening we are hosting two speakers from Comcast who will be presenting on the use of machine learning and AI at their corporation. For way of introduction, my name is Maria Rieders and I represent the Philadelphia Informs chapter. As for the format this evening, we will have two 20-minute presentations followed by about 5 minutes or so of Q&A. And what we'd like you to do as you listen to the talk and the questions come to your mind, just use the chat feature in Zoom to post your question. And now it's a great pleasure for me to introduce our experts. We have going first Ranjit Jangam, who is head of data science at Comcast. He has a background in industrial engineering, a master's from University of West Virginia, and has been managing AI and machine learning portfolios for over 14, 15 years. He's a data-driven innovator, has prior experience from the insurance industry, and is now leading those efforts at Comcast to drive growth, risk management, and the customer experience. And following Ranjit will be Rama Machahanam, who is Director of Machine Learning at Comcast. Her background is in process control. She has a PhD from the University of Massachusetts in Amherst, and also some background from the Wharton Schools at Executive Education Program. Her past experience prior to joining Comcast include JP Morgan and General Electric, and she's currently involved in customer optimization at Comcast using machine learning and AI. So without much further ado, I will hand it over to Ranjit, who will talk on the use of machine learning and AI to drive business opportunities.
Thank you, Maria. So I'm going to steal the screen from you. All right. Can you confirm that you can see my screen?
Yes.
Awesome. So thanks, Maria. So yes, Ranjit Jangam, I head the data science at Comcast. I've been with Comcast for about 3 years now, a little over 3 years. And as Maria mentioned, I've been with other industries in the past, again, primarily in data science space. So what I'm going to, the goal of this next 20 minutes for you is just to talk about machine learning best practices, and then how they are applied at cables and telecommunication industry. This is by no means, the only way to do it. There are other ways to do it. There are other use cases as well. But before I dive into my deck, I just want to talk about, there are multiple AI teams within Comcast. One of the teams that I lead is primarily focused on business, right? Primarily around business support. There are other teams like Rama belongs to a totally different team. And then there are other AI teams focused on reliability and engineering and so on. So this is one view of AI ML at Comcast that I'm going to talk about. By the way, welcome everybody. I forgot to mention, welcome everybody. Thank you for listening in. So first thing, what you see on the slide is we build solutions at scale and to support end-to-end life cycle of consumer, right? So when I say consumer, we've got new customers who are not yet, prospects, basically, they're not our existing customers. And then there is subscribers, that is existing customers, right? So we build solutions, everything that revolve around the consumers. There are 4 key areas that we focus on. How do we drive revenue? How do we manage cost? How do we improve customer experience? And how do we improve loyalty and retention, right? Customer loyalty and retention. How do we get there? We break it down again into 4 different pillars. We've got sales and marketing, where we talk about who's likely to convert, who's likely to respond to our marketing campaigns, what are their preferred products of engagement, or the products that they're likely to subscribe. Are they likely to add other products during their tenure with Comcast? How engaged are they in the products? And then retention strategies, right? How do we mitigate churn? Maximize retention? Then a little bit about NPS. I'm not sure if everybody knows, it's Net Promoter Score. We've got, it ranges from 0 to 10. Ideally, we want customers to give an NPS of 9 and 10, meaning they're likely to recommend Comcast for the services that we provide. So we want, there is a transactional NPS, there is a reliability NPS. Focus is primarily on both. When somebody engages with Comcast, we want customers to give us a score of 9 to 10. When they use our services, we want the services to be reliable. So we want them to give a score of 9 to 10. So focusing on NPS, how do we optimize NPS? How do we minimize calls into the call centers, make sure that the customers are able to self-serve themselves, right? Maximizing customer lifetime value and so on. The last piece, and this is digital and personalization. It's all about personalized recommendations, right? When you visit Amazon.com, you buy something on Amazon. For instance, you buy Amazon Echo, right? A device by Amazon. The next time you log in, it shows devices similar to Amazon Echo. That's a personalized recommendation to your liking, right? So when you log into Netflix, because you watched Game of Thrones, this is a show that's very similar to Game of Thrones, right? So that is personalized recommendations. How do we make that kind of recommendations and recommender systems? So that's what we capture. I will walk you through a few applications, to give a little more color and flavor. So moving on to the next slide, here what you see is, again, the intent is not to teach how to build models, but I want to focus on the 4 boxes in brown that you see. Those are the 4 areas I want to talk about. But I do want to walk through the whole cycle though, starting from top right quadrant. Obviously in a model building process, the first thing is, what are the objectives? Is it goal? Again, remember I talked about the 4 points: driving revenue, mitigating risk, managing cost, improve experience, and so on. Identify the objective. Second is unified data source, right? 85% of the time we spend time on prepping the data. We want to have a centralized data repository. Engineers on our teams, they engineer this data from 250 different sources, and they create this master data set that gets refreshed at a certain cadence. It could be daily, it could be monthly, it could be quarterly, and then there are data quality checks in place. So when you have this centralized data repository, you minimize your time on data prep, you minimize the time on data extraction, data quality checks, and so on. And you speed up the process on building the models. You focus more on the algorithms that you use to build the model. So this is an important step. Also in this, we scale the raw data into additional dimensions, right? So for instance, creating new elements like min, max, vectors, and you can do so many things. So this is a key aspect. Again, the focus is to create a centralized data repository that basically lives on top of, X number of tables underneath, that minimizes the time it takes to extract the data. Then, standard train and validation, you build the model, you validate it, you can use all kinds of algorithms you want, depending on the use case. Then we deploy the model, right? At Comcast, in my portfolio, we have about 100 plus models in place today. So we can't, score or refresh the model scores manually. It has to be automated process where, again, there are data quality checks before we release the model scores to end users and so on. So that is deployment, and we use a lot of open source tools, Kubol, Airflow, XPS, just depending on the tool. Then the other piece, right after you deploy the models in production, the key thing is disciplined experimentation. Statistically, as statisticians, we evaluate the significance of the model. But how do we know that the model is actually working well in the market, in the field, right? So you need to follow the principles of disciplined experimentation, A/B test. Compare business as usual versus model-driven campaigns. Do you see any lift? If you see lift, then the model is working and it's intended for the use that it was built for, right? So that is an important thing. Then governance. Governance is another piece that, at least I'll use myself as an example from my prior life. Not much emphasis has been on governance. We don't know who's using the models, how they're using the models. Are there test plans in place? So whenever you want to use a model, you need to run a test. That again, disciplined experimentation, track the test results, monitor the model performance over time. You built a model in Jan 2019. Is it good to be used today, right? Governance is a key aspect. And the last piece is data closed feedback loop, right? All the tests that you run, it's kind of reinforced learning. The models you use to test, the models that you test, you want the test data back, feed that back into the models to refresh and improve the performance, right? So the key emphasis, I want to focus on the 4 boxes: centralized repositories that minimizes the time to extract the data that goes to data quality checks. Second, disciplined experimentation of everything that we build. Third, governance is a key aspect, tracking down the usage, how they're used, the results of the test, and so on. And the fourth piece, access to the test data. So this is an overview of the modeling process. We basically try to practice all these steps in model development. Now, let's move on to the first application, right? So I mentioned briefly, it's a 360-degree of a view of a consumer that we build solutions for. The first thing is, preferred engagement channel of consumers, right? Knowing the channel that the customers like to engage with companies is important. If I visit xfinity.com, Comcast website, you can actually, that tells me that Ranjit is interested in engaging digitally. So maybe email is a better way to communicate. If I call into the call center, Ranjit wants to talk to somebody over the phone, right? They don't like email, not necessarily they don't like, but they prefer talking to somebody. If I visit a store, a Comcast store, Xfinity store, we've got one of the amazing, really good stores in Philadelphia, right? So visit the store, that means that tells me I like to talk to somebody in person, right? So the way you engage with, how you like to engage plays a big role. How that leads to how do we want to target the consumers? How do you want to engage with the consumers? A preferred channel engagement model, right? 3 channels, it's a standard multinomial model, 3 different levels. You've got some accuracy measure. Here in this case, we've used a random forest. You can use whatever method, GBM, whatever, whatever algorithm makes sense. Use it. And again, the key thing is we want to drive customer experience. You maximize the customer experience. You maximize the customer engagement. There's no point in reaching out to me via email when I like to talk to somebody. Might as well talk to me rather than sending me an email, right? So that's the intent, knowing the right engagement channel. Second application, right? Again, so I want to, even when I say knowing the right channel, it doesn't mean it's just about sales. It's also about existing customers, right? I like to pay the bill, but I don't want to talk to somebody. I want to have a feature where I log in and I can sign up for an auto pay, right? So that's digital engagement, right? So it's not just about new customers, it's about even existing customers. The second application is promoting the right product to consumers, right? So if I'm most likely to use Comcast internet service, does it make sense to recommend a video product to me? Probably not. I'm like, why do I need video when I don't like to watch videos? I like streaming, so I just need internet service, right? So knowing the right product and recommending the right product to consumers is very important. We've seen historically, recommending the right product maximizes your conversion. There's an increase in revenue. People tend to convert more. People like to engage more, and so on, right? So knowing the right product. So this is the standard, again, some kind of a multinomial model. Comcast offers multiple products, some of the products being, and again, this is by no means sales pitch for Comcast, but it's more about just the services, right? Telecommunication industries, internet, video, phone, mobile, home security. These are some of the products that we offer. So, or for the matter, any other telecommunications will offer. So, a standard multinomial model, multi-class model, again, any kind of algorithm you use. The other options you can do internet only likely model, who's likely to subscribe to only internet, who's likely to subscribe to a video. There could be an overlap, then you come up with one recommender system, right? So different ways of building the same solution, but the key thing is knowing what's their preferred product that they're likely to subscribe to. That's the second application. This helps drive, revenue, conversions, and improved customer experience. Third application is more about, I talked a little bit about unsupervised clustering, right? So I've talked about preferred engagement channel. We've talked about what products they're likely to subscribe to. Once they become an existing subscriber, we want to track, right? Are they happy with the service? Are they engaging with the product? Are they likely to cancel the subscription, right? So we do some kind of unsupervised clustering where we use first-party data, like demographic data, their product tenure mix that they have, their account activities, and we create clusters. Again, you can create clusters using different algorithms. It could be, K-means, which is pretty standard. You can use deep learning. You can use, hierarchical DB scan, whatever, depending on what kind of data that you have in place and, the distribution of the data and so on. And then the key thing is, I want to focus on the chart on the right. I hope everybody can see the screen, right? I can read it out. So the x-axis on the chart is basically the left of the axis is low engagement, right of the axis, x-axis is high engagement. The y-axis, as you go down, customers are having service issues. They try to engage with Comcast more, leading to poor experience and more cost to Comcast. As you go up through the vertical axis, the maintenance cost is high. Sorry, I think I flipped it. So the y-axis, if we go down, low service problems, low customer cost. If you go high up in the vertical axis, the maintenance cost is high because customers are not happy with the services. They keep calling into the call center. Ideally, in this grid, you want to be in the bottom right quadrant where engagement is high, the consumers are happy with the service, the consumers are they don't call into the call centers as much. That's where you want to be. All the other segments that you see is area of opportunity for Comcast to mitigate risk, improve the customer experience. For example, right, if there is one segment that says less engaged consumers, one option we have, for this customer consumer bucket is we can drive engagement. Hey, did you know that the X1 remote, video remote, you can talk to the remote and change channels without actually typing in the number of the channel, right? So in educating to drive product engagement, or downgrading them, right? They're not using video as much. Let's right size them, right? Let's say, hey, what you're not using, would you like to drop your video and increase your internet speed instead, right? So sizing them right, giving them the right product. So these are some of the strategies that you can do with this unsupervised clustering. Again, following the 360-degree cycle of a consumer from them being a prospect to a customer. The next application is along the lines of the product most likely I said, right? Once I'm a subscriber, I start off as an internet customer. Am I likely to add video products, right? So if I'm likely to add video products, again, trying to upsell them to other products so they engage more with Comcast products. I like internet. Guess what? I may like video too. So upselling them with video products, improving retention and loyalty and so on. That's basically your next best upgrade. The fifth is, we focus heavily on risk as well, right? Risk could be defined as many things. It could be customers likely to cancel the subscription, customers likely to drop their products, customers likely to lower their tiers, right? Higher internet tier versus a lower tier. They may cancel the subscription without making payments, and so on. So we've got churn propensity models, video drop propensity models, who's likely to be delinquent because of a life stage changes, right? Somebody lost a job, so they most likely cannot make the payment and so on, right? So this helps you managing your revenue, maximizing customer loyalty and so on. So a lot of focus on managing the risk as well. Next piece is, this is a different kind of customer segmentation. What I talked about earlier on is more about first party data. Now, this is where we focus on attitudes, right? So there's a difference between attitudes and what they actually do. Attitudes is where I want to do something, like, I want to drive a Lamborghini. Whereas the actual behavior is, guess what? I don't drive a Lamborghini. I drive a 4-door sedan. That tells me that maybe I cannot afford a Lamborghini, or I have family with kids. It doesn't make sense, right? So differentiating between attitudes and then actual behavior is important, because you want to go towards the customer attitudes, what they want to do. You want to build products, you want to market products such that you cater to the customer attitudes. And how do we get this data? We conduct surveys. We gather this data. For example, are you a technology enthusiast, right? Do you like streaming? When you get these responses, you cluster the customers, and then you get one segment such as technology enthusiast. That tells me that products that we build should cater to this technology segment. For instance, our X1 remote is a great example. It is, you can talk to the remote, you can flip channels, you can do all kinds of pause and so on, right? So fancy things in a cable TV remote that jives well with technology. So you want to focus on a 5-year strategy that helps with go-to-market strategy, product strategy, and so on. That's another application where we focus primarily on customer attitudes. A quick time check. I think I'm right on time. This is my last slide. So I talked briefly about 100+ solutions that we have in place, right? And then some of the other solutions is personalization. We do a lot of models for .com. When somebody visits Comcast.com, in other words, Xfinity.com, how do we make the real-time recommendation for the consumers, right? What products are they likely to take? Are they likely to sign up for an auto pay? Are they likely to reboot their modem online, right? Personalization. Customer lifetime value is a key aspect. We focus a lot on survival models, using different methods like Cox, proportional hazard method, or other, some geometric distribution that you want to fit, like Weibull or whatever, right? Next best recommendation. Amazon is a great example, one of the pioneers in next best recommendations. I buy shoes. Shoes are very similar to socks. Recommend socks as well, right? So somebody has Netflix today, Peacock, a Comcast NBC product. It's very similar to Netflix. Recommend that too as well. So, that is, so we build algorithms using collaborative filtering and reinforcement learning. I've already talked about retention strategies. Last piece is identifying customer intent proactively, right? Am I likely to call into the call center? If I'm likely to call into the call center for a question on the bill, maybe it's helpful for us to send an email proactively. Hey, did you know that the bill increased because of the XYZ reason? So identifying the customer intent and proactively reaching out to them to maximize their customer experience. So these are some of the applications catered towards the business side that my team primarily works on. I apologize if I went too fast. Again, I was trying to hit the 20-minute mark. I hope, you take something back from what I've just shared. That's all I have, Maria.
Thank you. Thank you very much, Ranjit. I'm going to give people a little time to maybe jot down a question in the chat feature. I have a question for you that I very often get from our students. I teach undergraduate students as well as master's and PhD students, and especially the undergraduates, they are curious. So what kind of tools do we need to have to work in this machine learning AI environment? What would you recommend that students equip themselves with?
So this is like a paradigm shift, actually. When I started off back in the day, SAS was the only tool that was available. Now SAS is, as a great tool, but then since then, there are a lot of open source tools that have come up, R, Python. They're pretty good tools. They've got really good libraries and functions that you can actually use. Now, it has evolved. If you want to focus on heavy process intensive tools, there is PySpark, Scala that people are learning, right? These are some really good, amazing tools, functionalities that have amazing AI/ML capabilities, that are easy to learn and implement and deploy.
Thank you. I don't see anything right now in the chat feature. I'm just gonna invite the participants to keep posting questions if they have them. I think Ranjit is gonna hang out for a while. Here are some questions. What sort of tools are needed to manage the data science processes?
As I mentioned, right, so there are multiple tools. For instance, let me, as I mentioned earlier on, to build, you can use any of the tools that I mentioned, SAS, R, Python, Scala, PySpark, whatever. But to deploy the models into production, right, where end users can access the model output, you need to deploy them using some kind of automated tools, workflow management tools such as Xgears, Cubole, and so on, right? That's one of the tools where people can access. A precursor to even building the solutions is engineering the data. So if you're an engineer who's focused towards data science, you could do a lot of Java programming, and all kinds of SQL and, MySQL, all kinds of engineering tools that you could use to engineer the data. So these are the three primary things that we use in-house. Outside of this, there are a lot of AI ML tools that are evolving in the industry today. For instance, DataRobot is a great AI ML tool. Obviously, you have to pay for it. It's, it depends. They're generally Comcast. We're investing in DataRobot for a year just to see how the tool plays out. But it's auto UI. It's machine learning automation where you don't have to code anything. You just drag and drop, and you feed the data. It builds the solutions for you. DataRobot is a great tool. Data IQ is another great tool for deploying the models. You don't have to rely on open source. It is, again, license, you have to pay for it, but still, right, great tool for deploying the models into production and evaluating the model output as well, right? Monitoring the drift of the model over time. So these are some of the tools that you can use to manage data science processes.
Another question that has come up is, how do you evaluate if a model has degraded?
So, depending on the model, so typically what we do is, when you build a model, you can use, I'll keep it very simple. If you're building a conversion likely model, you look at multiple statistical criteria to evaluate the model performance, right? You look at, your area under the curve, or you look at the KS, or you look at the gains chart, right? So that is how you pick your best model. And to monitor the performance over time, you compare the model performance from the development time frame to the current time frame. For instance, the model was built in Jan 2019. We are in October 2020. So do the performance, when I rerun the model today, do I get the same KS? Do I get the same lift? Do I get the same area under the curve using today's data, right? If I don't get it, if there's a deviation of X points, we basically say the model is degraded. And the thing that we use is population stability index is what we use to monitor. If the PSI is greater than 0.25, we say that the model has deteriorated and it needs to be rebuilt.
And there is another question here that kind of goes back to what I had asked originally about opportunities for students. But this person is asking, how about academics who are interested in becoming involved in industry? Do you have any good places where people can collaborate? What's a good entry point for those kinds of collaborations?
Absolutely. I mean, I'm going to use Comcast as an example. We've got a great co-op and internship program in place. I know that my team, I've got three interns and one co-op lined up for 2021. So that's a great starting point. Look out for our advertisements. We visit our careers page. We are looking for co-ops and interns. That's a great thing. Back in 2019, and again, because of COVID, we did not do it this year, but back in 2019, we do some kind of partnership with various universities, again, local universities around Pennsylvania, Philadelphia, where we partner with them. We have the students work on a certain project for us, again, the things that we are not able to dedicate time to, we pass on those projects to students who are in this data science space, right? But keep in mind the precursor, to get into Comcast, into data science spaces, some kind of an advanced degree that is revolving around statistics, some kind of mathematics, or myself, operations research, or a physics major, or some kind of even computer science, where you've got some exposure to building mathematical models, right? So, and that's one way, as I mentioned, interns, co-ops, we partner with universities, just to work on some projects that we don't get time to work on. And the third piece is we are going to be starting 2021, again, depending on how COVID evolves. We also visit universities as well, to looking out for projects and students, just to engage with them, because we also want to keep ourselves updated with the latest technology, latest curriculum that's happening across the globe, right? So we do that all the time.
So you're saying this goes through all the levels, not just with respect to students, but also collaborations with researchers.
Absolutely.
Academic researchers. Nice.
Absolutely.
Question here from the audience: what do operations researchers need to learn to get involved in your field of machine learning, artificial intelligence?
I'll give one example, right? Operations research, the first thing that comes to my mind is, traveling salesman problem, right? That's a very standard problem that we have. And that's a standard problem for Comcast as well. For instance, technicians, right? Technicians visit homes to fix internet problems. So we try to identify the right path for the technicians to drive to make sure, your commute time is less and you're hitting more homes to fix the problems rather than spending more time on the road, right? So that's one of the use cases where we use operations research at Comcast in my portfolio. I'm sure Rama can talk to it more than I do, but that's one of the use cases of operations research at Comcast.
Well, thank you very much. I think we are in good time for the second half of the program. If you were to unshare your screen, Ranjit.
Yeah, I think I stopped sharing my screen, right?
Yeah, then Rama, you can go on and share your presentation. So Rama is going to speak on the use of machine learning to predict customer out-of-home network service issues. So she's going to dive into one particular application.
Can everybody hear me okay?
Yes,
And do you guys see my screen?
not yet.
Not yet. Okay, let me stop sharing and try one more time. Okay, I am not seeing. Okay, let's share. Do you guys see my screen now?
It just says started screen sharing. Hold on a few seconds. Sometimes it takes a little while.
Yeah, it may just take a little bit of time. Oh, it says screen sharing is paused. Stop sharing. Give this one more try. How about now?
Yeah.
Okay.
Success. Thank you.
Wonderful, wonderful. Third time's a charm. Hi, everyone. My name is Rama Mahajanam, and I started working for Comcast in January of this year in the applied AI team. I lead a team of 8 researchers, and they are primarily focused on machine learning involving troubleshooting solutions to improve the customer experience. So when I got started with Comcast, I joined late January. So I had the pleasure of being on site for just 1 month, and then COVID hit. So really the use case that I'm going to talk about today is about how we coped with that and actually came out stronger. So I'll talk about predicting outside of the home issues that during COVID-19 that my team was able to come up with a wonderful solution for all of the technicians out there that Ranjit was referring to that go out and service customers' homes. So the problem, and if you can see my screen right now, the problem really for the company was that, with COVID hitting and lockdown that ensued, we could not allow our technicians to enter inside customer homes and actually go in and do any kind of troubleshooting whatsoever. But on the other hand, internet access became, even more important to everyone, because as you can see, we are doing a Zoom meeting right now. And so it's very important. It became super important to remain connected to everybody. And, like schools were having virtual schools and everything. So the number of issues that got reported also went up. And we have what is called an Xfinity Assistant. If any of you guys have Comcast for your internet services, you probably have that as an Xfinity Assistant app. And you can access that app through, either your mobile application or on the web or, other channels as well, like Facebook Messenger and so on. So basically what customers do is they go in, they enter an issue, they go into the Xfinity Assistant, they enter an issue, and before they even do that, my team predicts that they are having internet issues or TV issues and helps them to troubleshoot. So we took that one step further and we said, let's try and predict that a technician will only need to work outside of the home to fix the issue. So that's really the use case that we are talking about here. And there's several ways that we can do this. We could look at a lot of telemetry data, and I'll go into some of that detail later on in the presentation. But basically what you're trying to do is you're trying to look for 2 devices within the home that have the same type of issue. If they are having the same type of issue, then it's likely that if both devices are having the trouble, then the problem is outside of the home. So to put it very simply, if one of them is having an issue and the other one's working just fine, then that just means that there's some wiring issue inside the home, and that can be fixed. So those kind of trucks were not rolled out at that time during COVID. I think Comcast is back up now, but we are still trying to isolate our technicians as much as possible and have them work from outside of the home. Right. So with that, let me just quickly walk you guys through the triage process, and you'll see that this is pretty important. if you actually want to isolate the problem to outside of the home. So a customer calls Comcast with an issue, and here we're talking about the regular phone calls that customers call. So when they call the customer, when they call the agent would go in and they have what is called a troubleshooting procedure. So they follow that. And when they've run through that procedure and done some premise health checks and so on, they would require that they basically determine that a truck roll is required. So this is what's called a trouble call. A TC is a trouble call. And then a special request truck is rolled out because during COVID, we had only special request trucks going out. The technician then arrives at the site, and they start their job. And basically, what would happen is, for the sake of COVID, we actually added two things. We added what is called an X meter test, which is conducted at the ground block, and a speed test, which is also conducted at the ground block. If both of these tests, and especially the X meter tests, turn out good, then it basically indicates that the problem is inside of the home, and that could be some kind of triage with regard to internal wiring or internal splitters and so on. If the test failed at the ground block, then the technician then runs a tap test, and if that fails as well, then that basically means that this is more of a network-wide issue, and a refer to maintenance tech is sent out. It's a different kind of technician that would go in and solve a problem completely outside of the home that affects several customers at the same time. And if these tests come out good, then it basically indicates a drop condition, and in which case the technician can absolutely fix the problem outside of the home. And this is really the sweet spot for us. If both the ground block as well as the tap tests are good, this is the case where it predicts that the technician can actually fix the home outside of the home. So this is what the model is going to use, and as you'll see in later slides, to predict that the issue for the technician was outside of the home. Right? So going on to the next slide. This is the modeling framework, and I'm sure many of you guys, if you are involved with data science, are aware of the modeling, the way models work, at least in the supervised learning space. You have features, and these are some of the features which are basically, you can think of them as inputs to the model. And then you have labels, which are really the outputs of the model, which is what we will be predicting. And you kind of saw some of them in the previous slide where, it could be that you need to remove a filter, or the technician might put these in as fixed codes. So we had these coming in as fixed codes from the technicians as output. So we looked at historical data, over 1 million records, and basically built features using all of these telemetry data, and then go in and actually use these inputs and these labels to build a training set, which then would predict whether the issue was inside or outside of the home. And then for any test case that came in, basically what our model did was every morning we had a job running, which would take the data from the previous night, develop these features, and then predict how many customers have issues that are outside of the home. And this was then used to guide the agents who said a truck roll was required outside of the home, and a truck roll outside would happen based on our model predictions. So this was actually a trial that we did in the second quarter of this year. A very successful trial. Of course, the volume of trucks was not as high just because of COVID. So to delve a little bit more deeper into some of the data sources and the features that we used account level data. So this is very much based on what are the types of devices that they had in the house, what is the tenure of this customer, how long has this device been active, and when was the last time it was installed, and features like that, which are customer specific. And then we also looked at prior truck history. So has this customer been having a lot of problems? And all customers are basically aggregated at the node level. So we were looking at how many times has this node experienced issues in the past, which is a strong indicator for an issue happening with this customer in the future. And then we looked at several tools, and these are algorithmic tools that are constantly polling the customer's device. So the device or the modem is the gateway that was polled several times during the day to look at whether or not there is connectivity between the CMTS, which is the backend system, and the modem, the customer's gateway itself. So we look for network impairment at the node level, and several streams upstream of the customer as well. So taking all of these features into account, we then went in and typically, as we would do for machine learning applications, went ahead and aggregated these features at several levels. And we built what are called node topology maps. And what these are basically, you can see here, you have a customer, you have a node, and then for RF issues, you would look at several RF elements downstream of that node, and the taps, which we talked about earlier, which could feed a single home or could feed several different homes at the same time. And then when we aggregated these telemetry value markers, as we call them, at various tap levels, we were able to compare similar pieces of equipment for different customers. And let's say, this tap had failed, we could see that all three of these customers were impacted. And if we could solve this problem, then it would actually improve the experience for all of these customers. So that's kind of how we went about the machine learning model and developing the features or the inputs to the machine learning model. Right, so the next step was to actually run the trial, right? So the trial was underway, and we now had lots of rich data coming back from the technicians, and they were actually saying yay or nay. So we would send them a prediction of a model which said, this account on this customer is having a problem outside of the home, and they would actually go out, check it out, and say yes or no to us. So we had a lot of rich data, and that's what we call as the ground truth labels in here. But as you guys probably already know, machine learning needs a ton of data. And like I'd mentioned before, we had 1 million rows of record of historical data. So we wanted to use this ground truth labels that's coming back very well. We wanted to take advantage of this opportunity and say, can we build label functions working with some of our subject matter experts? The SME translates into subject matter experts. So we built label functions around that. So for instance, the X meter readings that I talked about earlier were indicative of a problem outside or inside of the home. So we used that as one of the labeling functions. We used our ground truth label as another label function, and so on and so forth. So we built several labeling functions working with the subject matter experts. And then we came back with more data, more training data that helped increase the accuracy of the classification model some more. So that was another added benefit of doing this trial that in the second quarter that the technicians were able to participate in, right? And so just to go back into the model results itself, with the trial, we were able to prove out that the model achieved at least a 77% precision at 5% recall. And what was very interesting to us is that the tools that we had talked about on slide 5, where we could use those tools to identify whether there were degradation of network features. Many of them stood out, and you can see connectivity between modem and CMTS as being the key features that stand out in the model as the top contributors that would help us discriminate between an inside or an outside issue. So when this was tried out, I mean, it was a great success, and people, the operators, the technicians who went out and actually went to customers' homes. I had one of them come to my neighbor's home even, and they actually reported that they could go about their job, do their troubleshooting, complete everything all outside of the home, and without even having to disturb the customer. And the customer had much better experience working with them as a result of that. Right, so these are some of the results, and we have another group that actually does some rule-based predictions What we did as part of this trial and using the tech surveys, which is really the technicians giving us feedback about whether or not we were accurate. If you look at that, the sixels, when you compare them versus the ML model, the model does phenomenally better than the sixels. And this is just over a short period of time. And there are some overlaps between the model as well as the rules. So both those cases are included in two of these. But the bottom line and the takeaway for us as a business was that you could use AI to actually improve your precision and have less less redundancy and less errors in actually rolling out trucks to customers' homes to solve issues when they are inside of the home or outside of the home. So yeah, this is actually now being extended to be more of a network side, to identify network side impairments that can then be used to solve customers' issues. Right? So the conclusion was that as a result of this trial was really that machine learning and AI could really help out improving the customer experience. And we could use the beauty of this approach, and the way we proved it out was that we used the subject matter experts and increase the training data that was available to the model, and at the same time AI could go in and be like that pivotal tool that helped to improve the precision and help customers experience a better service and keep their internet up at a point when they needed it the most. So that's basically all I had. So we do, and I think we are on time, so we should be able to take a few questions as well.
Thank you very much, Rama. Interesting example. I know that this probably is a question as much for you as it would be for Ranjit. There's one question on the chat feature that we haven't gotten to before, and that was, what's the mix of data scientists and data engineers in your team?
Yeah, I can go first. So my team generally, the data scientists are about 16, I believe. Engineers are close to 10 to 12. Again, within the data scientists, we've got a very good mix of, data scientist level 2, which is a starting level. Then there is senior data scientist, there is lead data scientist, there is principal, then there are directors, and then there is me. In the engineering, the structure is very similar, but the titles are slightly different, but generally the same kind of mix, 10 to 12 engineers and about 16 to 17 data scientists.
Thank you. Any other questions?
Sure, on our side.
Go ahead, Rama. I'm sorry.
Yeah, no, I was just going to say, on our side, we have a DevOps team. So we have, in my team, they're all machine learning researchers and data scientists. So they're all PhDs with their masters in mathematics or computer science, and they primarily have advanced degrees. Yeah, I think all of them are PhDs. And then we have a DevOps team which does the engineering and the platform work for us, and that would be another 8 or 9 engineers. And these guys are actively involved in actually helping us build the data pipelines. And so we kind of have a clear demarcation of data scientists versus data engineers that way.
And Maria, somebody I think asked me about data robot. I accidentally shut down. I don't know if the message just came to me or that was for everybody. I think it was Joe. But somebody asked me about data robot, right? I think if you don't mind, Maria, can I answer that question?
Absolutely.
Yeah. So the question, I believe I closed it without reading it carefully, but I think the question was, data robot does all kinds of models. I mean, it's a very unique tool where, it's basically auto ML, right? Auto machine learning. You just feed the data. It's going to create clusters on your raw data that can be used as input into the models. It does all kinds of, machine learning and natural language processing, use that as features in the models and so on. I think the question was, since it does all kinds of models, do we rely on data robot or do we rely on internal, right? So the way we break it down is we use auto ML tools primarily for operations and maintenance. What I mean by that is 100 plus models in production, right? We have 100 plus models that we deploy every month or some on daily basis. So what happens is you can't dedicate time for every single model we build. Some models, the overall ROI using that models, you don't get much benefit in terms of the full objectives for me. So when we have that kind of models, which limited ROI, return on investment, we try to use machine learning automation because, automation is pretty good. But models that are heavily dependent, that are used across the board, like, for instance, the consumer segmentation I talked about, it's used across the board. So we want to dedicate more hands-on people to do hands-on modeling, investigate different kinds of methods. So it depends on the use case. Generally, our machine learning automation we use for models that are simple in nature, limited usage, the ROI is minimal. But human intensive models are those that are, more exposure to different stakeholders, high revenue driving or customer experience kind of focused models. That's the difference.
So I did find the question that you're referring to, and specifically Joseph wanted to know, do you find fitting subsequent data sets leads to the same models having the best fit, or do alternative models become the best fit?
Yeah, it depends. It's kind of, to me, it's kind of a chicken and egg thing. Generally, the more the data, the merrier. But again, you have more data, but you don't use the right algorithm to fit that model. Guess what? You won't get a good output. So I believe it's best of both worlds. As much data as possible to begin with, and then use the right algorithm to maximize. So we generally have like a benchmark versus champion versus challenger situation. Every time we build a base model, we try to beat the performance of the base model before we deploy.
And since this is a fairly technical audience, there's also interest in learning a little bit more about specifically which algorithms you use. And you have mentioned some of them. I think random forest was mentioned. So is that one of the leading algorithms?
So we actually, random forest is one example that I gave. Actually, my team is, so good thing about, I think, Rama, please feel free to chime in as well. But the good thing about our teams, I think, are we don't have any tie-up to a certain tool. So when I talk about 16 data scientists, I'm pretty sure Rama has the same thing. They can build models in any tool and any algorithm they want. So SAS, Python, PySpark, R, Scala, H2O, just name it. Algorithms, random forest, GBM, XGBoost, standard regression models, neural nets. Rama kind of was into neural nets there. I talked about collaborative filtering. So it's more about the objective that we're trying to solve. If it is a binary outcome, conversion, yes, no, then guess what? It's regression, it's random forest, it's XGBoost. If it's a continuous target where you're trying to build something like a credit score or something like that, where you can use generalized linear regression models, or you could use XGBoost too. When you get into complex algorithms like similarity matrix, like customer product to product similarity, right? Then we use, cosine similarity, some kind of collaborative filtering, right? So it all depends on the kind of algorithms, the objective. Then the algorithms come in later. Survival, right? You can use logistic regression for survival, from churn probabilities, or you can use Cox proportional hazard method. So I think that it depends on the algorithm we use, depends on the objective we are trying to solve. There is no restriction. I know one person, Jingjing on my team, she came up with something new, which we haven't done before, structural equation modeling, right? You try to create some kind of an unsupervised modeling where it captures latency, hidden latency in the data, right? So all kinds of unique algorithms we experiment, whatever is used for the right use case.
Yeah, and I think there was some kind of question there on which model we had used. I think the modeling approach that I showed, we used XGBoost because it was, typically an imbalanced data problem, and there was the class that we were trying to predict, which is the outside class, was quite low as compared to the other. So yeah, to the rest of the problem. So we used XGBoost. But primarily what my team does is more reinforcement learning, because we are trying to preempt the customer from asking their question. So we are in the Xfinity Assistant, when the customer comes in, we're trying to give them a predictive card, by which I mean, so we are, even before the customer has typed anything, at the hello, they get a predictive card saying, hey, we noticed that you're having internet issues, or we notice you're having TV picture quality issues, that sort of thing. So that's something that is more aptly handled by the reinforcement learning algorithms. And we are using a specific form of that called contextual bandits, which is a simpler form of reinforcement learning than you would use if you use the entire reinforcement learning approach. So yeah, my team is more focused on reinforcement learning, but for simpler problems like predicting outside of the home, we tend to use XGBoost or random forest in some cases. But yeah, for the most part, we tend to focus on GBM, XGBoost, and those kind of tree-based algorithms.
And just one point to add, reinforcement learning applies a lot in my portfolio as well. When we do the next best recommendations, right? You make a recommendation, the customer doesn't like it, you don't know what, right? So that we do a lot of reinforcement learning in our space as well for recommender systems.
Awesome. Well, I'd like to take the opportunity to thank our speakers, both Raman and Ranjit. This was really interesting to see what happens right here in Philadelphia at Comcast, and hopefully there will be future opportunities for collaborations between academics and industry problems at Comcast. For those of you who don't know much about our local Informs group, I just want to point you to the website of our organization. Informs is the Institute for Operations Research and Management Science. It's really an international organization with over 12,000 members. And we have a local chapter right here in Philadelphia that tries to bring together researchers in academia, applied people in industry, just anybody who's interested in operations research, management science, business analytics, data science, whatever you want to call it. And we organize some of these meetings to foster those collaborations. Hopefully in the next year, we can have in-person meetings again, but in the meantime, we have enjoyed the virtual speaker series. Again, my heartfelt thank you to today's speakers. And if you want to learn more about Informs, become a member, check out the website. And if you have any suggestions for future topics or speakers, feel free to contact us. Thank you very much, and good evening to everybody. Bye-bye.
Thank you.